Hello everyone, we are from Group 4 and today we would like to present to you about the concept of displacement current. So in this video, we are going to have an introduction to the displacement current, following by the Maxwell equation related to the concept, as well as some practical and real-world example of the concept. First of all, let us go through the introduction to displacement current. In electromagnetism, displacement current is defined as an electric current created by a time-varying electric field rather than by moving charges. The development of the displacement current can be traced back to a famous physicist named James Clerk Maxwell, whereby he predicted that a magnetic field must also be associated with a changing electric field, even in the absence of a conduction current. A theory that was subsequently verified experimentally. As magnetic fields have long been associated with currents, the predicted magnetic field also was thought of as stemming from another kind of current. When a conductor is connected to a capacitor in series, the dielectric material, which is perfect dielectric, will be used. For a proper dielectric, the sigma is always equal to 0, which means that no current is allowed to pass through this material and resulting to no conduction current. Therefore, in order to produce the value in ammeter, the concept of displacement current is applied, whereby the current flows is now due to changing electric field instead of electric charge. Displacement current plays a prime factor in a range of fields such as the propagation of electromagnetic radiation, like radio wave, light wave, and through empty space. Besides, a traveling, varying magnetic field is everywhere associated with a periodically changing electric field that may be concise in terms of a displacement current. Next, I will pass to my teammate Nuli to talk about the Maxwell equation.
I will explain about the discussion on Maxwell equation related to the concept of displacement current in electromagnetics. Displacement current has the same unit and effect on the magnetic field as is for conduction current depicted by Maxwell equation. From this equation, curl of H is equal to current density and displacement current density. H is related to the magnetic field, which is B equal to mu H. Mu is the permeability of the medium in between the plates. Here are the integral forms of Maxwell equation. For the Ampere circuit law, closed surface integration of H dot dl can be converted into point form, which is curl of H equal to current density and displacement current density. This equation is also a Maxwell equation for time-varying field. In addition, Maxwell equation can be in the static field and time-varying field. This equation is for Gauss' law. This equation is for Faraday's law, and this equation is for Ampere's circuit law.
After that, I'm gonna talk about the application of displacement current. So we're choosing one practical or real one example of displacement current concept and briefly explain its working concept. So the example we choose, which is the triple electric nano generator, we're going to do some small briefing about it. So the triple electric nano generator, as known as TANG, was found in 2012. The Wang fabricated a triple electric magnet nano generator, which is the TANG, which can effectively convert various mechanical energies into electricity. The advantages of it are the large output power, low cost, simple production, and the high conversion of efficiency. So As the diagram shown, the tank is two metal layers contacting each other. So, about the working principles, we can see at the as the figure. So, the two triboelectric materials will come into touch when an external force is applied to tank. So, look at the diagram 2, and the charge will pass between the two materials. One material surface with a greater ability to attract electrons will produce negative charge in this situation, which we can saw at the upper layer of it, and the positive charge will apply on the lower layer, as the diagram shows. So, when the external force is released, an electrical potential difference is established because of the separation of the two materials. We can see that on the figure 3. So now we're using the equation down here when open circuited, which is the VOC equals to sigma D divided by the epsilon naught, where the sigma is the charge density and the epsilon naught is the vacuum permittivity, and D is the separation distance in an point condition. So, to balance the potential difference that produce, the charges will flow from one side to another side until the device is fully released, which we can saw at the figure 5. Once the force is applied again, the potential difference will descend because of the reduction of the interlayer distance. This process corresponds to an opposite current flow, as displayed in the figure 6. Thus, the tank engenders an alternative current AC pulse output during a periodic switching as presented in the figure 4. So this is the small process of the working principle of the tank, which is the triboelectric nano generator. So thank you. That's all from our group 4. Thank you for lending your ears to us. Thank you.